Our Earth has lots of different elements such as oxygen, hydrogen, chlorine, and many more. There were many attempts to arrange these elements into proper table. To understand how these elements were arranged, let's look at today's lesson.
The content standard of this lesson is classification of elements. At the end of this lesson, you are able to identify the position of matter, non-matter, and inert gases in the periodic table, differentiate the characteristics of matter and non-metals, appreciate the order of elements that exist in nature that has allowed people to organize them in the form of a table. As of 2016, scientists have already discovered 118 elements. Not all of these elements occur in nature. Some elements are synthesized in the laboratory. In order to study the properties of elements in a more systematic way, scientists have classified all the discovered elements into the periodic table. Periodic table is a list of elements arranged in the order of increasing proton numbers. Proton number is the number of protons inside the nucleus of an atom. The periodic table divides elements into groups and periods. The vertical column of the elements are called groups. The horizontal rows of elements are called periods. There are 18 groups and 7 periods in the periodic table. Elements in the periodic table are grouped as metals, semi-metals, and non-metals. Inert gases are non-metals that are arranged in group 18. Next, let's look at some examples of metals, semi-metals, and non-metals. Examples of metals are sodium, magnesium, calcium, copper, and zinc. Examples of semi-metals are boron and silicon. Examples of non-metals are carbon, nitrogen, oxygen, helium. Metals and non-metals are elements that are distinct in their chemical and physical properties. All metals are solids at room temperature with the exception of mercury, which is liquid at room temperature. Metals and non-metals can be easily distinguished through experiments. Let's see one by one. What are the differences between metals and non-metals? Let's look at the appearance of metals and non-metals. To find out if the rods have a shiny or dull appearance, rub one end of a rod with a piece of sandpaper. Note whether the rod is shiny or dull. Metal has a shiny surface. Non-metal has a dull surface. Ductility is the ability of a material to be stressed into wire. A material is ductile if it can be drawn out into wires. It is not ductile if it cannot be bent or stressed. Try to bend the rods. If the rods can be bent and stressed without breaking, they are said to be ductile. If they break when bent, the rods are said to be brittle. Metals can be bent without breaking, so metal is ductile. Non-metals breaks. Therefore, non-metal is not ductile. Malleability is the ability of a material to be hammered or pressed into shape without breaking or cracking. Metals are malleable. When hammered, it becomes flat without breaking. Non-metal cracks easily and becomes shattered when hammered. Therefore, non-metal is non-malleable. Next, let's look at electrical conductivity of metal and non-metal. Prepare a simple electrical circuit. To complete the circuit, clip both ends of the rod. Observe the bulb. If the bulb lights up, this indicates that the rod conducts electricity. If it doesn't, then the rod is not a conductor. As you can see, the bulb lights up when a metal rod is used. Metals are good conductors of electricity. Can a rod made of sulfur, a non-metal, conduct electricity? Electricity cannot flow through the sulfur rod when the switch is turned on. Therefore, the sulfur rod is not a conductor of electricity. However, there is one non-metal that can conduct electricity. Carbon is the only non-metal that can conduct electricity. If non-metals are poor conductors of electricity, are they also poor conductors of heat? An apparatus is set up as shown. Two thumbtacks are attached to one end of the copper rod and carbon rod with wax. The other ends of the copper and carbon rods are heated simultaneously. The order of the thumbtack falling off is observed and recorded. Thumbtack on the copper rod falls off first. The thumbtack fall off because the wax holding them soften when heat energy is transferred from the hot ends to the rod. This experiment shows that metal is a good heat conductor, while non-metal is a poor heat conductor. Therefore, they are good heat insulators. Next, let's look at the melting point of metal and non-metal. Sulfur powder, a non-metal, melts when heated because it has a low melting point. Iron filings, metal, remain unchanged when heated because they have a high melting point. Unlike metals, non-metals have low melting point. What property of helium make the balloons float? Helium is a gas with very low density. Therefore, another property of a non-metal is that they have a low density, whereas metals have high density. Next, let's make a comparison on the properties of metals and non-metals. Metal has shiny surface, non-metal has dull surface. Metal is malleable, non-metal is not malleable. Metal is ductile, non-metal is not ductile or brittle. Metal is a good heat conductor, non-metal is a poor heat conductor. Metal is a good electrical conductor, non-metal is a poor electrical conductor except for carbon. Metal has high melting point, non-metal has low melting point. Metal has high density, non-metal has low density. Tensile strength is the maximum load that a material can support without fracture when being stretched. Metal has high tensile strength, Low metal has low tensile strength. Next, let's look at some examples of metals with their characteristics and uses. Aluminium. Aluminium is a grey and shiny solid, strong and light, ductile, malleable, good conductor of electricity and heat, and highly resistant to corrosion. Aluminium is used to make aluminium foils, food and drink cans, kitchen utensils, aircraft parts, and high voltage power lines. Iron. Iron is a grey solid, strong, ductile, malleable, and conduct electricity and can be attracted by magnet. Iron is used to make railway tracks. Copper. Copper is a reddish-brown solid, ductile, malleable, rust-proof, and conducts electricity. Copper is used to make electrical wires, heating pipes, and roofing. Zinc. Zinc is a strong, rust-proof, ductile, and malleable solid. Zinc is used to make roof tiles. Next, let's look at some examples of non-metals with their characteristics and uses. Iodine. Iodine is a purplish black solid, toxic and antiseptic. Iodine is used to make antiseptic medicine to protect wounds against bacterial infection. Chlorine. Chlorine is a greenish yellow gas, toxic and bleaching. Chlorine is used to make bleaching agents. Sulfur. Sulfur is a yellow powder and toxic. Sulfur is used to make insecticides, fireworks, paints, and cleaning agents. Sulfur can also be used to harden rubber tires. Carbon. Carbon is a black solid, light, smooth, and can conduct electricity. Carbon is used to make brackets, pencil leads, and electrodes in dry cells.
What are the advantages of grouping elements in the periodic table? The ultimate advantage of the systematic arrangement of elements in the periodic table helps us to study the elements systematically, especially in their physical and chemical properties. Therefore, we must be thankful to the scientists who have found and arranged the elements systematically in the periodic table. A lot of time was spent on researching the characteristics of these elements. That's all for today's lesson. Thank you.